Hello everybody, welcome to the Calc-gebra 3 video. Please watch this video to complete Calc-gebra 3 in your independent study packet. This packet is due on August 6th. Please remember that you can pause, rewind, or fast forward during this video. Okay, turn to part 1 and we're working on number 1. We're going to show that this awful looking thing is equivalent to 15x squared plus 2 all divided by 2 root x. First, put your over ones. Now we're going to fix our numerators and denominators. So the square root of x is in a numerator and 6x is in a numerator. 1 is in the numerator. 2 is in the denominator. X to the negative 1/2 is in the denominator. That's equal to the square root of x in the denominator. And now 2 plus 3x squared stays in the numerator. Okay, so now we're talking about an addition problem. To add these fractions, we need the least common denominator, which is 2 root x. So we're going to multiply the numerator and the denominator by 2 root x. Right here, we have a multiplication problem. It literally says 2 times root x times 6x. Now, root x times root x is x, so you have 2x times 6x, which is 12x squared. That means we have 12x squared divided by 2 root x plus 2 plus 3x squared divided by 2 root x. Now that we have a common denominator, we can add the fractions together. You can see that we have 15x squared plus 2 divided by 2 root x. Check. Number 2. First, put your over ones. Now we have to fix the numerators and the denominators. So 1 plus 4x squared stays in the numerator. 5 is in the numerator. 2 is in the denominator. 5x all to the negative 1/2 goes in the denominator. That's the same thing as the square root of 5x in the denominator. 8x stays in the numerator. Root 5x stays in the numerator. Now we have a subtraction problem. The least common denominator is 2 times root 5x. So we're going to multiply this fraction over here by 2 root 5x all over 2 root 5x. In the first fraction we can distribute the 5. We'll get 5 plus 20x squared divided by 2 root 5x. Minus. Now over here we have a multiplication problem. We have 8 times x times root 5x times 2 times root 5x. It's a big multiplication problem. If you want to, you can rearrange 8 times 2 times x times root 5x times root 5x. We're using the commutative property there. So you have 16 times x, and the square root of 5x times the square root of 5x is 5x. That gives us 80x squared. That means we're subtracting 80x squared divided by 2 root 5x. Now that we have a common denominator, we can bring the fraction together. We can combine like terms, and we see that we get 5 minus 60x squared all divided by 2 root 5x. Check. So now you should be able to do 3 and 4. Please turn to number 5 now. We're going to simplify this complex fraction to obtain this. We'll start off the same way. Put in your over ones. Now we're going to organize our numerators and denominators. 2x squared plus 1 goes in a numerator. 5 goes in a numerator. 2 goes in a denominator. X to the negative 1/2 goes in the denominator as root x. 4x stays in the numerator. 5 root x stays in the numerator. And downstairs we have 2x squared plus 1 squared divided by 1. This is a complex fraction. The LCD is 2 root x, so we will multiply the numerator and the denominator by 2 root x. It helps to put over 1. Now we're going to distribute. In the numerator, once we distribute here, we see that 2 root x cancels. So we're left with 5 times 2x squared plus 1. Over here, we have 4 times x times 5 root x times 2 root x, all over 1. And in the denominator, we have 2 root x times 2x squared plus 1 squared. In the numerator, distribute the 5. We get 10x squared plus 5. Now, we're noticing right here we have a major multiplication problem. It says 4 times x times 5 times root x times 2 times root x. If you find it helpful, go ahead and rearrange the terms right now. 4 times 5 times 2 times x times root x times root x. You can see now that we have 40x. Now, root x times root x is x, so that gives us 40x squared. That means that we're subtracting 40x squared in the numerator. The denominator all stays the same. At last, in the numerator, we can combine our like terms to get our negative 30x squared plus our 5 divided by 2 root x times 2x squared plus 1 squared. Okay, so now we should be able to do 6, 7, and 8. Now turn to part 2. We're going to factor completely, and we're going to rewrite without a fractional or a negative exponent. In order to factor completely, I recommend circling both groups. Now look carefully. There are some things that both groups have in common. For example, both groups have an x plus 1 squared in common, and both groups have an x minus 3 in common. So right now we are talking about GCF factoring. When you're talking about GCF factoring, we should remember this tip. Take out the lower of the exponents. So in this case, the GCF is x plus 1 squared and x minus 3 to the first. So that means we're going to take out an x plus 1 squared, and we're going to take out an x minus 3. When we do that, we're left with 2 blanks. In the first group, we're left with an x plus 1 to the first, and in the second group, we're left with a 4 and an x minus 3. Finally, we're going to simplify what's in here. We have x plus 1, and if we distribute the 4, we get 4x minus 12. If we continue to simplify, we have x plus 1 squared times x minus 3 times 5x minus 11. So you should now be able to do 2, 3, and 4. Okay, let's go down to number 5, and again we should circle the 2 groups. This is a GCF factoring problem. In this problem, both groups have an x to the 1/2 in common. Remember our tip, we're going to take out the lower of the exponents. When we have a common base, which is x, we're going to take out the lower of the exponents. That means we're taking out an x to the 1/2, and when we do that, we're left with 2 blanks to fill in. In our first blank, we're left with x to the 4/2. You can check that if you want over here, because x to the 1/2 times x to the 4/2, remember, same base, we should add the exponents, is x to the 5/2. Check. In our second group, we're left with a 1. Okay, simplify a little further. X to the 4/2 is the same thing as x squared, so we have x squared minus 1. That means we have the square root of x times x squared minus 1. Now it does say to factor completely here, so we can go a little bit further. Root x times x plus 1 times x minus 1. Number 6, we can start off by circling the two groups. The common base here is x. This is a GCF factoring problem. So both groups share an x to the negative 1/2 in common. Just remember to take out the smaller of the exponents. That means that we're taking out x to the negative 1/2, and when we do that, we're left with two things. In our first group, we're left with x to the 4/2. Again, we can go over here and check that if you want. X to the negative 1/2 times x to the 4/2 is x to the 3/2. Check. In our second group, we're left with a minus 1. So now we can simplify a little bit further. X to the 4/2 is x squared, so we have x squared minus 1. You can think about numerators and denominators for a minute. X to the negative 1/2 gets moved into the denominator, and we have to make the exponent positive. So we know that we have a square root of x in the denominator. And it does say to factor completely, so we have x plus 1 times x minus 1 divided by root x. Okay, so you can finish 7, 8, and 9 on your own, and don't forget to check your answers with the solutions on the last page. Part 3. Simplify the expression using two methods, A, adding or subtracting the fractions, and B, factoring completely. If applicable, rewrite without fractional or negative exponents. Let's skip to number 2. In part A, it tells us to add the fractions together, so the first thing I'm going to do is put an over 1. In order to add fractions together, we need a common denominator, so we're going to multiply by the square root of x squared plus 5 over the square root of x squared plus 5. If we do that, we'll get x squared plus 5 all over the square root of x squared plus 5 plus 1 divided by root x squared plus 5. Now that we have a common denominator, we can combine like terms. We get x squared plus 6 divided by the square root of x squared plus 5. For part B, it tells us to simplify by factoring. It might be helpful to rewrite these in terms of fractional exponents. So we have x squared plus 5 to the 1/2 plus x squared plus 5 to the negative 1/2. The common base here is x squared plus 5, so that means our GCF is x squared plus 5 to the negative 1/2 power. So we're going to take out an x squared plus 5 to the negative 1/2. And if we do that, we're left with two things. We're left with x squared plus 5 to the 2/2 in our first group, and we're left with a plus 1 in our second group. We can do a quick check of that over here. x squared plus 5 to the negative 1/2 times x squared plus 5 to the 2/2. Remember, we have the same base, so add the exponents. That's x squared plus 5 to the positive 1/2, so it checks. Okay, that means we have x squared plus 5 to the negative 1/2. In here, x squared plus 5 to the 2/2 is just the same thing as x squared plus 5. We still have a plus 1. X squared plus 5 to the negative 1/2 belongs in the denominator. So we have the square root of x squared plus 5 in the denominator. And then in the numerator, we're left with x squared plus 6. So now you can do 1, 3, and 4 on your own. Please check your solutions with the answers on the last page.